spying.
You're online.
Okay.
Okay, I think we are online. Today, come closer, guys, come closer. So today Amanda is not with us because Amanda hates science. Amanda, anything science, Amanda is just yuck. I'm Dr. Abbasi for Essence.
This is Misha. I'm Jimmy.
Okay, we are going to talk today about the science of rainbow. Now, many thousand years ago, people looked at the sky and they saw these colors. What do you think what they thought?
God.
God, heaven.
Yeah.
Beautiful, right? What? Possible.
Not 100 years ago.
Many years later. No, but, and what's important that always when it happened, it just happened 99% after rain. And rain is good. Rain is life. Farmers love rain, right?
Yeah.
So farmers love rain. The rain comes, and just in the afternoon, all of a sudden, that beautiful thing is in the sky. So what do you think? I mean, first of all, why after rain? Why afternoon? Okay, you answer me the first one. Why after rain?
More humid. So there's more water
Droplets, water droplets. Yes,
yeah,
you're right.
water in the sky.
No, it's not just humidity. It's not.
Okay.
It is, and it's not rain because rain is falling down. It doesn't stay long enough. Often not. So it needs to be water droplet in the air, small enough that they are suspended, that they don't fall fast, and small enough as well that they are not like a drop of rain, like a teardrop, but they're really round or more or less, because water that is too heavy, it drops and it has like a shape of the droplet, but the water that is small enough, the tension surface tension keeps it literally suspended in the air when it's small enough, and it keep it round.
So like a mist.
Yeah, you can say mist. Yes. But why in the afternoon? Have you ever thought about that?
No, does it have anything to do with the sun's angle if it hits?
Perfect. Exactly.
So I have a question to follow
Yeah.
up. Does it differ from the northern hemisphere versus southern hemisphere?
No,
it's always in the afternoon.
It's always has to do with the angle of the sun.
The angle of the sun.
Now, the sun has to be behind you. So theoretically as well, you can see it as well in the morning. But in the morning, usually, humidity and so on doesn't create that condition often enough. But so it has to be that, and that angle has to be between 14 and 17 degrees. Did you know that?
Nope.
Okay, now, why would that angle between 14 and 17 degrees?
14 and 17 degrees. So around here.
Okay, well, let's say this is a droplet of the light or something. A droplet of the water in the air. The sun, imagine this is round, okay? This is not round, but imagine it is round. The sun has to be at an angle that when it hits, first of all, it's like a prism. It goes from air to water. The fraction index, like light, literally slows down and it breaks. And the different light frequencies, wavelengths, they break at different angles. So let's just take one of those lights, like a blue or green or whatever. It comes in, it hits it, and it angles.
Yep.
It hits the other side of the droplet. Most of that goes through, but part of that reflects. Reflects.
I'll reflect back.
No, it comes in, it reflects.
So what's the difference between reflection and refraction?
Refraction is when the light change the angle.
Yes.
Reflection is when it hits and then goes.
Oh, okay.
Goes
I
to
see.
the mirror.
I see.
Sure.
Okay.
Sure,
A prism refracts, a mirror reflects. Okay, so it comes in, it breaks, hits it, and then it goes
Some
out,
of it goes.
and then breaks again and goes to your eye. So sun is behind you, you're here, and he's the droplet. And that angle needs to be between 14 and 17 degree, I believe, for you to be able, because if the angle is higher, when it comes here, it reflects outside of the earth. It still does the same thing, but on the curvature of the earth, it has to be that degree that it's far enough, not too far that the light goes away, not far enough, or not too far, not too close, because the angle is important. The angle of the sun need to be between 14 and 17 degrees, so mostly in the afternoon or early in the morning. Now, imagine now the light comes in, it breaks the lights in, and different color, they refract and reflect at different location. So what you see is not one droplet, but trillions of droplets that they all behave the same way.
And
So practically when you look up at certain degrees that you're looking up, you see different colors sorted. So what are those colors? Green is not one of them, actually. I said green, but green is not one of them. It's a constituent of the sunlight.
really, green is not part of
If green is one of the things, look it up. Look it up.
red, orange, yellow, green,
Is green part of it?
Cyan,
Cyan maybe it is.
blue, purple.
blue.
Yes.
That's seven. That's how we were taught.
Yeah.
7 colors.
So, but
Violet.
and they break in that. Yeah, green is in the middle. Yes, it is actually. So and literally here, this is why I'm not sure if we can show it there, but this is how it breaks. Let me see if I can actually put it on the screen for people to see that. And there's another thing I want to show you as well. There's another thing I want to show you. That practically emphasize what that really means. Let me just share my screen for everybody. Okay, here we go. Oh, I'm not sure if it's sharing it or not.
Yeah, it's sharing the
It
top
is?
screen. Yeah.
Okay, good. So yeah, as you see here, we are having this droplet has to be at certain angle so that when it comes back to the surface of the earth, your eye can see them accordingly. And as you see what I mean by refracting in different angle, but then reflecting from the other side, obviously most of the light goes through. Now, look at that. Light is coming from top, reflecting here. What do you think what that means? You have the rainbow.
But the rainbow start with red on the top.
Well, let's look at the rainbow. Let's go and look at the rainbow. Rainbow.
Yeah.
Okay, well,
Day.
so
See,
you see,
there's
Red's on
red on the top, but here in the image, red is in the bottom.
well, it is, you see, when you see that, your eyes continue that, it's on the other side. It's a reflection. It
Oh.
goes to the other side.
It's a, oh.
Yeah, you don't see there where it's coming from. You see where you believe it would end up, like a lens, like something that
Mm.
you just continue that. And if you your eyes continue that, that ends on top.
It
And if you
refers
continue that,
again.
yes, that's how it works.
I have a question. It's a little bit off topic.
Yeah,
Do you
yeah.
mind answering?
No,
it?
no, go.
So I've heard rumors that
And
our
our gold at
our-
the end of the rainbow.
No,
the
no, no.
leprechaun. That where the leprechaun live? Is that your question?
no, that our eye actually sees things upside down, but
And that's not the
but our
question.
brain processes so that
As a matter of fact, our eyes, like a lens, we have one lens, that's a basic optic. Everything in our retina is upside down,
yeah.
but our brain interprets it the correct way. As a matter of fact, there are glasses
You know that?
that you
Yeah,
can,
heard of
they
that.
tried it in the universities, they tried it on college kids. They put a special glass that they turn it around. So at first people were confused,
Yeah.
but within days they got used to it. They could see everything normal, even though they were upside down. Then when they took the glasses off, then again
They
everything
can't
was,
function anymore.
they couldn't function for a few days and then they adjusted again. So our brain is very malleable to that. But
But in this case,
in this case, in any optical case, you don't see how they're coming here. Your eyes continues that, and when your eyes continues that, it literally end up seeing where you believe that would end. Okay, now there is a
wow.
now I'm gonna show you an actual rainbow.
I'm an actual
Rainbow.
You're not. You're not qualified.
What? Rainbow. So here, let's see if I can show you an actual picture of a rainbow.
images.
You need to search for actual rainbow.
Yeah, here is an actual rainbow. No, I'm not sure if that's a real, okay, let's see here. I want that like here. Okay. Actually, let's keep it that way. So do you see that rainbow?
Yes.
Do you notice that inside of the rainbow is brighter than outside? Why?
Oh,
Have you ever noticed that?
no.
No.
No, now you notice that. Look, next time you see a rainbow, there's so much physics you can do with the rainbow. It's amazing. So why is it inside of the rainbow brighter than outside of it?
Actually,
Because we have those lights reflected. There's more light in
It
between.
takes some of the light from outside of the rainbow,
Ref-
transfer it to inside of the rainbow,
The
and some of
reflection,
that
right?
is rainbow. Now, you remember that we said it has to be a certain angle. What happens below that angle? It combines below that angle, it combines against all those things together, and you see it as a regular white. Okay?
When
So
when all the
what
color
is
comes
certain
together.
angle, you see that separation of it. Above it, you have less light, but everything is together. Below that, all those are again combined, and you see the same thing.
So actually, in the middle, it's still part of the rainbow. It's just white. It's white
Yes.
rainbow.
Yes. Just the physics of it. Let's go back to the physics of it. Okay.
They're like bright light.
Just
That's why
brighter.
it's
So
more
here it
brighter.
is. See, between here and here, you see the separation of it.
Yeah.
But the light is not just coming only here, right?
Yeah.
The light coming from all different angles and everything. And if it takes the light from this area, transfer it to this area based on refraction and reflection. So you see more light that should be here, down here, and that becomes brighter. Except, have you heard of the double rainbow phenomenon?
I see a
Yeah.
lot
Have
of
you ever seen a
them.
double
Yeah,
rainbow?
yeah.
Yes.
See a double rainbow like a month ago.
Yeah, like in Minneapolis, right?
You notice that the second rainbow is actually the colors are reversed? Have you ever noticed that?
Let me pull it
I
up.
think
I had a picture.
Look
Let
at
me
the
pull
picture.
it up.
I think
See a
you,
picture.
I think you sent me that picture.
Yeah.
Actually, send me that picture. I want to put it up here.
And sometimes I saw like a sphere rainbow. I saw it once.
It is when you have a
When I was in the
that
state.
rainbow, the second rainbow is always outside of the first rainbow.
No, I saw a circle rainbow. Like,
Oh yeah.
Oh yeah,
The
look at
outside
that.
is from
And it is fainter. It is faint.
yeah.
It's always fainter, and
yeah,
it's
you sent me that picture.
Yeah.
yeah. So
This is cool.
ever wondered why? Number one, let's start with easy one. Why is it fainter?
Less light.
Yeah, but
Angle.
I know obviously
Angle.
less light.
Angle.
Well,
This is higher.
describe to me physically why is the second rainbow fainter?
Could it be that part, the top part?
Okay, well, look at that here. The first rainbow the light comes from here, hits here, comes out here. But the light is not just there. The light is as well is here, right?
Yeah.
So if it hits here, it goes up there. So meaning that if somebody's in space, we'll see a rainbow as well, right?
Yep.
But we are not in space, we are on the Earth. So what does that mean? You remember the light hits here, comes here, 90% goes through, 10% reflects back. Now imagine the light comes here, it reflects here, it reflects again back to us. So it comes here, here, back here.
And then again, you see
So it
through.
reflects twice inside of the droplet. So for that reason, it is fainter because every time it reflects, just a small fraction reflects, most of it goes through. But then, considering how it works, it hits here, if at certain angle, if it hits here, reflects here, then somewhere here and come back at us. So it is outside of the first rainbow. And then between the first and the second rainbow is dark. Inside and outside of the rainbows is again brighter. Not as bright as inside, because again, the double reflection phenomenon, right?
Yeah,
Yeah.
the inside is
Very
very
bright.
bright.
Yeah.
Mm,
Is that your picture that you took?
yeah,
It's beautiful.
yeah.
Yeah.
But I was in the rain.
Did you go to look for gold there?
No.
No? They say
I
Irish-
don't know that story. Do you know that?
No.
Okay.
We don't know that.
in Ireland, they think at the end of the rainbow, the leprechauns are live at the end of the rainbow, and leprechaun hold gold. So it's a myth that, if you go to the end of the rainbow, certain people become gay, but other people find gold.
Can you actually go below a rainbow?
Yeah, can you actually find
No.
the end of the rainbow?
This is the rainbow is an
So
optical
so
illusion.
if you keep chasing the rainbow, you will always
It will-
keep
once you-
moving
Okay, so
until it fades away.
Until the mist are
Here is the
gone.
moisture.
Um,
Obviously, by the time you walk, the moisture is gone. But let's say you are in a fast airplane, you fly below. Actually, I did. Actually, okay. I'm a pilot. I have a small plane. When you fly, see at this angle, you see it.
Yep.
Once you come outside of that angle, there's no more
There's no
rainbow.
reflection. Yeah.
There's no more rainbow. But if let's say humidity goes forever, then the rainbow always will be.
So you'll be
same distance
chasing
to
the
you.
rainbow.
That's why they say you can get gold because you
Oh.
can never reach it.
So one, it will just fade away. Two, you can never chase it.
Well,
You can never reach it.
literally the reflection, you're outside of that reflection, or if the moisture goes forever, it will just move away from you because only that angle you see the rainbow. So
So is rainbow a 2D things? Or is it
rainbow is
3D?
what?
2D or 3D?
Rainbow.
Is it like on
Well,
the paper?
Okay, well,
Or is it something that's
okay, well, let me ask you the question in a different way, Jimmy. It's a philosophical question. Am I 2D or 3D?
you're 3D?
But do you see me 3D or do you see me 2D?
2D.
Yes,
It's a
yes,
projection.
yes. Everything you see is a 2D.
But if
But the
I
phenomenon is a 3D.
yeah, but if I model you, you're a 3D person, you have back, front, back, left,
Yeah.
right.
And so
For
is with the
rainbow-
rainbow.
Oh.
The droplet is not just in one plane, it's everywhere.
So the rainbow
But
actually look like
only-
this.
So again, let's hear. So sun here in your back, Jimmy's here, the droplets are everywhere. But only certain part of the droplet will reflect it to you at certain angle. Further you move, the angle will change. Closer you come, the angle will change. And then once you are out of that 14 to 17 degree angle,
Just
the
disappear.
rainbow is there, but you don't see it as a rainbow anymore.
Yeah, it's there, but you just can't see. it.
Yeah, so, but that's a good question. Is there anything you see is 2D? We don't see in 3D.
Yeah.
Our brain put that together and make us understand the concept of 3D, but look at that. I don't see 3D. Even if I'm looking with two eyes, I still see 2D and my brain interprets it as a 3D.
Mm,
Isn't that amazing that we never thought of that? That we think we understand 3D, but that's as well an illusion that our
just illusion.
brain cells, they combine this picture is here, this picture here, my eyes are this far, that for that reason, this should be closer than the other one, and so my lens are focusing this much. So it is actually amazing how we are making
3D movie.
3D concept of 3D from 2D. So same thing here. Okay, and as well, that explain as well why when it reflects red down, but then when you look at it, because again, your brain doesn't really see the droplet. Your brain sees where the end of that ray would be. Continues that, like when you look at the mirror, what do you see? Your brain says, okay, this is a mirror, but the person is somewhere else. But actually, you see that person in the same distance in that direction. That's why you can't fool somebody with mirror, right?
Yep.
Okay. So optic is one of the most interesting things that you can bring physics close to the children. So, and there are these optic sets. I recommend to every parent, get some of that and experiment with your children. So I want to get the double rainbow concept as well for you here. Double rainbow.
So is it true that all the rainbow is a circle actually?
No.
All the rainbow is what?
Like
Or
a
a circle?
Like an arch, like a
It's always an
circle.
arch. Why do you see the arch? Again, same thing.
I have seen a fully enclosed rainbow on sea
Okay.
once.
Well, it will be difficult to
It's
see that,
very
but
difficult.
yeah, but let me tell you why rainbow is always a rainbow, because once you move from certain area, literally the angle changes. Okay,
Oh,
so
yeah,
well,
I
that
saw
is
it
a-
on the
no,
sea once.
that is a different phenomenon.
Yeah, we'll
that's
talk about
different,
that
okay.
later, but let's see the double.
Okay,
rainbow.
so
There's a full
double
circle
rainbow.
up there.
Now here you see again, bright,
Oh.
dark, brighter,
And
Oh,
then
3-layer. Yeah.
and
is it
if it-
three?
no,
Two.
3 layer, but 2 rainbows. 2 rainbows, okay?
Bright, dark, bright.
No,
bright.
this is makes sense to you, right?
Yep.
Here is definitely brighter than this, but not obviously as bright as that, again, because most of the light get lost to that thing, okay?
Yep.
So, and then if you look at the physics of it, you see that the double reflection phenomenon here. This is the regular, this is
Primary
the
and the
this is a double reflection that gives you the second rainbow. Okay, and look at that again. It comes down here, but your eyes see that continuation high up. You see the angle? For that reason, the second rainbow is always outside of the first rainbow. Now, the reason it is a bow is because imagine when I look at you, at those droplets, if you remember, we talked about the angle.
Yep.
So that angle could be this much, but that as well could be this much. But when you widen it and so on, that's why, like, at any point where I am, there is certain angle to certain bow in the sky, certain dome in the sky. That as long as you keep that angle, then that's why it's a perfect dome, because the angle must be always the same.
So if you're far away enough and high enough, leave enough space, it will be a circle one.
Well, if you put all those things, in a span, but for that, why is the circle rainbow so extremely rare? Because we talked about an angle. Imagine for you to see a perfect circle, sun needs to be behind you, and everything in front of you need to be moisturized sky. Maybe on the top of a mountain you can have something
You need
like
to be
that.
high enough.
Yeah, you like literally astronaut in the space that the sun is just behind them, and the entire Earth is full of moisture, would have a perfect angle for that, or somebody on a very high mountain with the. So that is why it's more rare, because of that angle.
Drone. A drone.
Yeah, a drone is high up
Yeah,
again, the same thing, right? If you're higher and you have all the moisture, then you can create this certain angle, because usually on the earth, the other part of that would be
On the
underneath,
ground.
on the
Yeah.
ground, and there's no moisture there. Okay, so I think that's enough for the physics of rainbow. Is there anything else you guys want to know about rainbow?
That's already
Mm.
a lot of things I want to learn.
So next time you see a rainbow, think about all of those things,
Yep.
and you see how, just with deduction and simple physics, how much you can discover
Yeah,
about the
Yeah, I
nature.
have one more question. So do different light wave travel at different speed once it's dispersed inside inside water or air for that sake?
That is actually such a good question. Now, for a long time, do you know who discovered the rainbow and not the prism and the different color?
Isaac Newton.
Isaac Newton, exactly. So for a long time, we didn't really understand the light. Eventually, we figured out the light, how fast it goes. And much later, we discovered that the electromagnetic wave travel at the same time, same speed, like with
With air?
in any medium.
Oh, in any
medium, the electromagnetic wave, they travel the same speed. Okay. And then we discovered, though, as well, that when light goes from visible light, goes from one medium to another, it reflects.
Oh, good.
Because the speed changes.
Travels slower.
Okay. Light, generally, we say speed of light is the constant, but it's constant only in vacuum. As a matter of fact, and I'm sure you have heard that there's nothing, no information can travel faster than the speed of light. And that's as well referred to vacuum, because you can slow down light in a medium that you can walk faster than light. That they have done those experiments, which is crazy, absolutely crazy, bunker. If you have a dense enough material, that light still can go through. Now, but electromagnetic waves, they don't all behave the same way. It's about how they interact with the electrons in the medium. So in vacuum, there is no electron, there's no interaction, so light is light. Electromagnetic wave is like all light, all electromagnetic waves, they go at the same at the same speed. Now, do you remember that we say light is electromagnetic wave? So it has two components, electric and magnetic. They aggravate each other. That's how they propagate. The electric component produce a magnetic Faraday's law. There are three to each other, remember? And then the magnetic part create the electric part, and then it just propagate more and more and more. Now, depending on the frequency, and the frequency is energy, right? We get from sun lots of high energy photons, like ultraviolet and so on. We use it, we take one ultraviolet photon and we use it and then send it back with the infrared, like 25 infrared. In this podcast we had previously, I asked you trick question. How much of the energy of the sun do we keep on Earth? Zero. No, well, at first we struggle to think, well, we use the energy of the sun and so on, but how much of the energy of the sun that comes to the Earth do we reflect back to the space? 100%. Yeah. Because if we wouldn't, Earth would be vaporized in a week.
Oh, okay? Sorry, it's a second.
Yeah, well, no, it's take more than that, but if you would really, you can calculate actually, if you would keep any of the energy of the sun, we would be vaporized. We would be, the temperature would be millions of degrees, because it would just increase and increase and increase. But so what do we really get from sun? Not the energy, we get the entropy of the sun. So sun send us those photons, we put them to good use, like water. You put it through your wheels, you move, but the same amount of water that comes in goes out.
Yep.
It just has less entropy.
Kept the Entropy.
Entropy. We are using entropy of the sun. Now, what I wanted to tell you is that once this light particle hit our atmosphere, and then it gets denser and denser and denser, the speed actually changes. Once they hit water, the density is higher. Once they hit the glass, the density is higher. Light becomes slower. And the light, depending on their wavelengths, they can interact with the atom. It just happened the light that is in the wavelength of what we see has the exact energy that interact with most of physical material. Like wavelengths that are too higher, they cannot exchange energy, so gamma radiation passes right through. And when they have so much lower energy, they cannot interact because, so in that range is exactly the range that they interact with the matter around us. That is why we see that. Because above and below, they don't interact, okay?
So it's actually a matter of observation. Like you observe the light in the medium like air versus you observe light in a medium like water.
No, generally, light in the frequencies that interact with matter is what we conceive as a visible light.
Yes.
Okay. Beyond that, like ultraviolet, it does interact
but we don't see
somewhat,
it.
but we don't see it because our eyes are not.
We
But
cannot see
when
it.
you go much higher, it is like, imagine, like, have you seen, imagine that I'm going to use an appropriate analogy. You have two dogs. They have to be the same size. Okay, coming. You have two dogs. They have to be same size to be to interact, mate with each other. If one of them is a lot bigger or smaller, it just doesn't. They don't interact with each other. They can try, but that is how light, photons, and electrons work. Okay, like if they're very high, they cannot exchange information or energy. And if it's too low as well, they cannot. That's why we see only in the medium area, and we don't see very high energy particle like gamma radiation or very low energy like radio waves. Okay? Some animals, they can see more than what we see, but even beyond that, when you go higher or lower, no living being can see that because the interaction becomes so rare. It's not zero because we know gamma radiation, we use it for X-rays. It's still they interact, but it's so little compared
No
to
need for
visible
visible
light.
light.
Compared to visible light. So with the same thing is that something is transparent is because the physical structure of that thing is as such that the interaction is minimum. Like air, water, glass, they still interact, but most of that passes through because interaction is minimal, whereas your shirt, it interacts a lot. And sometimes based on the composition of the material, they interact with one frequency more than the others. That's why we see color. Okay,
Yep.
so that's a different conversation we will have. Okay, well, that was a lot for physics
Of rainbows.
of rainbows. Okay,
Okay.
we should continue with the physics of sight.
Yep.
Okay, okay, thank you.
Thank you.
Thank you,
I'm Dr. Abbasi for Essence.
This is Misha.
Jimmy.